Hi, Cassie. How are you? Hi, Pedram.
How are you, Zhangjiu? Hi, Kathy.
Well, very good, very good.
I wouldn't miss this for anything.
I didn't expect you to attend the meeting, but it's a big surprise.
Well, I have to say, you know, IoT is fascinating, but more fascinating is my friend, Dr. Johari.
Thank you so much. This is a big surprise for me as well.
I miss so much.
Okay.
Yeah, I miss you all. So I hope that sometime soon I get a chance to travel to Buffalo and meet you in person.
Yeah.
Please.
Yeah. So actually, yeah, so we will have some more activities like Buffalo Wireless Day in the future. Hopefully, we will do it do in-person meetings in the future. This year, we can only do remote meeting for now.
Sure.
But actually, this also makes the meeting easier. So we are able to invite many more great speakers, even from other countries, which is basically almost impossible if we do in-person meeting. But in the future, we may do hybrid meeting, some on-site meetings, some remote meetings, which can be a good idea.
Sure. Yes, absolutely. Sounds like, you know, with all the hard times that we have these days, one of the benefits of, you know, these days is basically people starting to feel a little bit more comfortable doing meetings online. And as you said, hopefully in future, you will be able to invite more people without having all the hassles of traveling from one side of the country to the other.
Okay, I think it's almost the time. So let me just give a brief introduction of our speaker. Okay, everyone, good evening. So welcome to EE701 Internet of Things from Technology to Applications. In this class we have an invited seminar, which will be given by Dr. Pedram Johari and on Lora implementation challenges. A technical breakdown from hardware design to user interface. So Dr. Johari is an associate research scientist at the Institute for Wireless Internet of Things at Northeastern University in Boston. Boston is a great city. Under the direction of Professor Tommaso Malodian. Pedram has received his PhD actually at UB in the same department, electrical engineering, in 2018 under the supervision of Professor Joseph Jonet. He has served as the CTO of an IoT tech startup in New York during 2018 and 2019. Pedram has also served as adjunct instructor and later as a research assistant professor by courtesy appointment at the UB in 2018 and 2019. His research interests are in low-power wireless IoT, vehicle communications, intra-body communications, and networking, and Internet of Medical Things. Okay, guys, during the presentation, feel free to ask questions in the chat area. I will collect all your questions, and we will do questions after the talk. Okay. So all of you are strongly encouraged to ask questions. Okay, so next I will make Pedram make you the co-host so you can share your screen.
Sure.
I think here we go. Okay, now take it away.
Sure. Thank you, Zhangjiu. Let me first make sure that I can share my screen correctly with you guys. And okay, can you see my screen right now?
Yes.
And is that the fullest screen of my first slide?
It's a full screen on my computer at least.
Sounds great. Because these days we are using different platforms and different software to do online meetings, and each of them have their own features. And sometimes I'm using a couple of the screens. Just wanted to make sure that I'm sharing the right thing. Sounds good. So hello everyone, and welcome to this talk today. Thank you, Zhangju, for the nice introduction. As Zhangju mentioned, I did my PhD at University at Buffalo, and I have always had the honor to come back to the university for different reasons. One of which is giving talks for Zhangju's course, and of course. I've had a great time at University at Buffalo back then, and I will take any opportunity that comes my way to come back to the university and sort of pay back what I've learned and the nice time that I had at University at Buffalo. Right now, I'm at the Institute for the Wireless Internet of Things at Northeastern University, working with Tommaso Melodia. Mostly the work that we are doing here is related to the Internet of Things with different applications. And currently I'm involved in vehicular communications, RF emulation systems. If you have heard about the Coliseum system, is one of the things that I'm currently involved with. And also a little bit of research related to my PhD, which was about intra-body telecommunications. And specifically right now we are thinking about some applications of seizure prediction and applying deep learning and machine learning stuff to intra-body communications. So without any further ado, I will start this presentation today, which is mostly based on the work that I have done back in 2018 and 2019 for a startup company in New York City. This was an IoT company, specifically working on Lora technology, although we have investigated the Sigfox as well a little bit, but we were mostly focused on Lora. So the title of the talk is Lora Implementation Challenges. I'm not going to go through any of the theories that I'm sure that Zhangju has already done a great job on talking about all the theories and learning the physics and whatnot. But right now, I'll be mostly focused on the challenges that you may face out there in the industry, whether it be working for other companies in the same area or starting your own company. And I hope that these will be useful for you. I do have somewhere around 20 slides, so I'm not going to take more than 35 to 40 minutes of the time. And then right after that, I will be happy to take any questions that you may have. So this is the outline of the talk today. We'll start with the Lora Network overview, just very briefly, a couple of slides, just a reminder of what you have already learned. Then I will spend a big portion of today's talk on Lora end devices. We'll divide it into two sections, the hardware and the firmware. In the hardware, I will talk about the design considerations and what are the things that you need to consider when you want to design your own Lora end device rather than using what you can find in the market. And then of course, the hardware needs to be complemented with the firmware, and we'll talk about the firmware and the skill sets that you need to learn. Then after that, we'll talk about the Lora network topologies. This might sound like a surprise to some of you that you have been working with Lora, but the truth is Lora can be used both in star topology that I'm sure that you are all familiar with, where you have a gateway or a base station and a bunch of end devices. It can also be used in a P2P topology, in which you will have basically, let's say, two end devices communicating directly with each other. We'll talk about this in details in future, in future slides and a couple of slides from now, but that can have quite interesting applications, and I will show you some of the examples. Then after that, we'll have the Lora network and application servers. Of course, this will be mostly software work, and for the people who are mostly interested in working in softwares and computer science and those type of stuff. But at the end of the day, when you have your hardware, when you have your network, you will need to connect these things together and then give that as a service to the users, which will be basically your front end applications. And after that, we'll just review what we talked about. And then I have one more slide that I added this year that I found it probably useful for new students who are graduating. in which I will talk about the skill sets that are, in high demand in IoT market, and what are the things, what are the tools, what are the software that you guys may be interested in to, focus on and learn it very well, so that you will be successful in your job interviews, or if you want to do research, what are the top hot topics research that you want to pursue in academia. All right, so introduction about the Lora network. Again, I'm under the assumption that you're already pretty much familiar with the basics and the theories, but some of the definitions. LoRaWAN is a media access control. Basically, it has the MAC protocol for wide area networks. And it's important to know that LoRaWAN is slightly different from LoRa. When we talk about LoRaWAN, that's specifically the MAC layer. That's the part that people will say, okay, LoRa is only working in the star topology, but the truth is LoRaWAN is for the star topology, right? And then the LoRa is basically just a physical layer of this technology. This is essentially, the LoRaWAN is designed in a way to be useful in long range and low power wireless communications. As you know, the data rate is usually very low in LoRaWAN, but of course there are applications that you do not really require high throughputs, but you just need to have a very low power, long lasting device and long range that can communicate, whether it be sensor data or in many other applications that I'm sure that you guys are familiar with. Then, as I mentioned, the LoRaWAN can be mapped to the second and the third layer of the OSI model. The second layer will be the MAC layer, and the third one will be the data link layer. And then it's basically implemented on top of what we call it LoRa, and that's your physical layer. And the physical layer is the spread spectrum modulation, the cheap spread spectrum technology. This has been first used in this application. Of course, it has been used in radar communications for quite a long time, but in this new application, it has been used first back in France, which was acquired by Samtec in 2012, and then they started to put it in different standards, and they founded the LoRa Alliance. Specifically, Samtec founded the LoRa Alliance. And then they developed a second and third layer protocol, which is, we call it LoRaWAN on top of that. And then they formalized it in different specifications. As far as I know, and I just double checked that, the latest version of the LoRaWAN specification is still 1.0.3, released in July 2018. But again, I might be mistaken here. It has been quite a long time that I have not been checking the latest versions. I know that they have a 1.1 version, which is ironically released in 2017, and then they have version 1.0.3, which is released in 2018. So I think this one is the latest one. And then what does the LoRa Alliance do? Is essentially forming the alliance. There's the Wi-Fi Alliance that you guys might have already heard about, and then there's the LoRa Alliance, which is essentially pretty much the same structure. So what they do is they are governing this environment, and they are putting the standards together, and they are promoting this technology. And of course, they certify the products that the products that come out of this technology, whether it be new devices that companies will create, or new applications that companies will create based on the LoRaWAN. If you want that to be certified, you can go to the LoRa Alliance, you will become a member, and you will ask for that certification. Being a member of the LoRa Alliance for a long time has been a discussion between people who are working with this technology. Is it really required that I become a LoRa Alliance member if I have a company out there, if I have a startup company who is using the LoRa? Well, the answer is in the gray area, right? Because this is ISM band and people are allowed to use that, but there are some benefits to be part of the Lora Alliance. So to be a good citizen, and if you have a large company, it's better to be the member of that Lora Alliance. And there are some perks that you will receive. Of course, you can have your voice being heard at the Lora Alliance. You can vote for the board members, today is the election day, right? So they have also board members, and you can vote there. And one of the key things that tech people care mostly about is the concept of net ID, which is the third bullet point that I have here. So if you're not part of the Lora Alliance, of course, still you can use that because that's in the ISM band and they want to promote this technology. And they have dedicated specifically 2 of these net IDs, which is 0 and 1. This is a 24-bit identifier. That is reserved for experimental networks, just what you guys potentially are doing these days in the class. But if you want to have one of these net IDs assigned to yourself, and you want to have roaming between one network and the other networks, if there are a couple of companies that are providing coverage of the LoRa, then that's the part that's the point that you need the net ID. There are different tiers. The institutional is free of charge. They do not give you a net ID. You'll have to use the experimental ones. Then there's the adapter version, which I took a look today, and I realized that they have raised the cost from $3,000 to $6,000. Sounds like it's a steal. They offer that for $3,000 for startups, if this is something that you guys are interested in. And then there's a contributor and a sponsor. As I said, the main difference is the type of the net ID that they give to you, and the power that you have in changing things and voting for different things. But quite honestly and frankly, I think the adapter is what you need if you're interested in starting your own company, and that's pretty reasonable price. There's a website that you can always check and make sure that you get the most recent updated version of what I explained here. With that, let's just start about talking about the LoRa end device. Of course, the end device, node or mode are different words that people use out there. But at the end of the day, it's just an object with an embedded LoRa communication device. It has a hardware, and then you have to develop a firmware for that. The hardware is essentially a LoRa radio and the antenna. Semtech SX126X or SX127X series are 2 different series of Semtech chips, which are essentially the LoRa radio chips. And then you will need a microprocessor that will communicate with this LoRa chip. And this is the part that you will put your download your firmware on that microprocessor or microcontroller, which can communicate to the LoRa, send the packets, receive the packets, running some basic algorithms. If you have a state machine that thinks about what is the state of the sensor, what is the next task that is supposed to do, that's all you need to basically put on your microprocessor. And then a variety of sensors and actuators. If you are monitoring a trash can, it will be a sensor, probably an ultrasound sensor that you will put on the trash can. If you are opening or closing a valve or a gate, then you will need some actuators. And then potentially some extra peripherals and interfaces. And of course, at the end, a battery. And the battery by itself is a very, I would say, challenging issue sometimes. Of course, this technology is designed in a way that it will not consume battery, but you may have many applications in which you will not have easy access to the end device. And you want to make sure that the battery consumption and the power budget, which I will explain a little more in a separate slide, you have considered all of these to make sure that your end device has its expected lifetime. On top of that, you will need the firmware, and that's the part that most of the people are using the LoRaWAN endpoint stack implementation. And they have this GitHub repository, LoRaMac-no, and they keep it updated. You can start from that repository and build your own basically LoRaWAN protocol on top of that. Or if you're working with a specific hardware out there, most of them already come with an SDK that company has basically prepared for you based off of the Lora Mac node repository. This repository is being moderated and monitored and contributed with Semtech, and that's what they have created. But as I mentioned, different companies has their own different version of SDKs based on that. More about the hardware. Of course, you can build your own hardware from scratch. So it might be very easier to start with one of the development kits that are out there, and most of them come at a very, I would say, cheap price. I don't know what is the range, but I guess around $10 to $20. Probably you can, buy one of these developer kits. And that's a reasonable choice. Of course, you will start with one of these evaluation kits or development kits because at the very beginning you have just an idea and you want to make sure that it works. You want to do some proof of concept. So you will go ahead and start with some of these development kits. But if that idea works well, and if you go ahead and present that to, some of the funding agencies, and you're at that stage that you want to form a new company and thinking about a real product out there, then that's the part that every penny and every cent, will be something that you need to consider, especially if you're talking about, in the world of IoT, you will have one device and then you want to reproduce that, maybe hundreds of thousands or millions of them, and you will deploy them to the field. Then that's the part that you will think about rather than using one of these off-the-shelf devices. You will start to think about creating your own device. There are, as I said, the SX126X and SX127X, which are two of the components, the LoRa radio components that are out there available. There's the microchip version of it as well. You can start with that and then have your microprocessor and the peripherals that you will need to complete your device. The other option that is out there, and that will be quite honestly the most cost-effective version of it. You will have your own PCB, you will start with the cheapest devices out there, and you will design it yourself, you will send it to a CM, and they will produce it for you. The alternative for that are the SIPs, or system in packages. And two of the examples that I have worked with before, there might be new ones that came last year, but the most updated versions that I still know are the microchip R34 and R35 and the ACC S76S modules. What it is essentially, it already has the LoRa SX12, let's say 6 or 7 inside of it. And beside that, it will have a microprocessor and a bunch of other, useful things that you will need. So they have put it all in one package for you, and all you need to do is to design a very simple circuitry. And as a matter of fact, I have worked with the ACC and microchip, both of them. The ACC one only needs to be connected to an antenna. Everything has been taken care of and has been put in this package. So you will just put that on a very simple PCB board, connected to a battery and an antenna. Of course, if you need more sensors, if you need more actuators, more keys and whatnot, you can connect them. But as far as the LoRa capabilities, everything is already embedded in this package. They also offer, I2C, SPI, UART, and different GPIOs. As a matter of fact, plenty of them, which could be, I would say, which is quite enough for any type of application that you can think about. So I would say if you decide to build your own device, rather than starting from the very basics, which was the previous slide, I would go for one of these system in package or SIPs. Next slide, I have the structure of one of these, and that's the S76S, which is one of the chips that we used at my previous company quite extensively. As I said, it has a microcontroller, so you don't have to worry about adding a new microcontroller. It has interfaces between the microcontroller and the radio unit. This is what Semtech provides. And then it has the crystal, and the RF front end also is already included in this package. So as I mentioned, all you need to do is just connecting that to an antenna. One of the topics, again, there are many things that we can talk about, but one of the topics that I see a lot of research being done out there, whether it be in university or in different companies out there, specifically, I think Keysight is really interested in power budget analysis. And if you guys have memberships there, probably you're receiving many of these emails from them. But this is a hot topic. Power budget analysis is one of the things that in IoT world in general is very important. Of course, Lora has this nice feature of being low power, but still you may want to very seriously consider your power budget. So things to learn here, and spend a little more time to have a deeper dive into the details, technical details on power budget is current consumption profile of the end device that you have. I'm sure that you're familiar with different transmission rates, like the DR0 to DR7 in Lora. So make sure that you learn and understand all of those, and come up with very intelligent algorithms that they can modify these based on the application that you have to save the power. Then during the transmission time, in most cases, your device consumes the highest power. And again, for Lora, you have the capability of change the duration of that pulse based on the rate that you will choose. So these are the things that you may want to consider and make sure that there's a balance between the coverage that you have, the reliability of the application that you are putting out there, making sure that you receive the data. But at the other side, sometimes probably you are consuming more power than what is needed. And you can always save that power, and hassles of battery replacement. And based on your application, you may need to also take into account the power consumption of the sleep time, reading a sensor, controlling an actuator, and different types of things that also consume the power. But as I mentioned, most of the power will be consumed during the transmission, and that's the part that you usually have a peak in your current consumption. And again, if you are interested in this specific aspect of devices, which is batteries and power consumption, it's really important to learn about the chemistry of different batteries, because that also plays a major role. The batteries usually come with a typical current consumption profile, and they have nominal values. Let's say you buy a battery for 500 milliamp hours. But in reality, it's really important to look at the datasheet of that battery and figure out that, okay, this measurement is done in constant current consumption, let's say at 1 milliamps or 2 milliamps. But then when you are drawing the current at 130 milliamps, it's not easy math just to multiply that or divide that by 130 and then come up with the duration or the life cycle of that battery. The chemistry of the battery really plays a major role here. And as a matter of fact, many chemical engineers are currently, this is a very hot topic, research, are working on different types of materials that they can use for the batteries that can handle peak currents. And as a matter of fact, IoT is one of the areas that requires batteries and serious consideration of power budget analysis. On the firmware side, deep understanding of LoRaWAN endpoint and stack protocol is really something that is necessary. The GitHub repository is out there. There are very well documented PDFs that you can find from LoRaWAN specification. I have the link of the GitHub here for you. A few slides back, I guess I had the specification PDF. We can always go to the LoRa Alliance website and download that. If you want to take this serious, you may want to learn that very carefully and seriously and understand the protocol there so that you can use it in your applications. As I mentioned before, most of the devices will come with their own SDKs, which will make your life slightly easier. There are some APIs that you can use, off the shelf, so you don't have to learn all the details of the Lora Mac. But again, if you're serious about that, you may want to develop your own code and SDK. Some of the things that you may want to take into consider when it comes to the firmware is the frequency band and device classes. I'm sure that you have learned about that in the class. There's a registration method in LoRaWAN, which is important. There's ABP versus OTAA. Again, most of the companies at the very earliest stage start with the ABP, but that gives you just limited resources. The OTAA version of it is where you have all the privacy and license controls and handshaking and stuff happens over the air. And that's a way more scalable version of the implementation. Of course, you can always work around with the ABP, but if you're talking about millions or tens of millions of devices, you will have to migrate to OTAA at some point. Adaptive data rate is something that is important to learn about. Again, I'm just throwing some words here. These slides will be shared with you, but I expect you, if you're interested, expect you to go ahead and search for them and learn more and more. But I just try to put some bullet points on some of the topics that you will definitely need if you're thinking seriously about LoRa applications and you're thinking about creating your own application and device out there. And the maximum transmitted power, again, that depends on many things, but you have to be careful of that as well. One nice feature that, again, right now it has been a little bit over 2 years. In October 2018, the LoRa Alliance announced that they have enhanced the LoRaWAN protocol with their new specification, which supports firmware update over the air. This is also a very interesting topic. FUOTA is different from OTAA that you see right here on top. This is a completely different thing. This is about the registration of the devices, but this one is how you can update your firmware over the air. This is also a very interesting topic. You may want to, if you are still working on your project for this class or in future, you want to utilize LoRa devices. This is one of the topics that you may want to focus on and come up with some very nice applications. In general, what it does is basically if you have hundreds of devices out there already deployed in a city or let's say whatever environment in a company, and if for whatever reason you want to update your firmware, adding some new features, or if there's a bug in what you have programmed already on devices, it sometimes it's not really easy to go ahead and take that device and reflash the firmware with a new firmware and then add the new features or resolve a bug that you already have on that device. This nice feature will let you update the firmware over the air. In other words, you have your device already deployed in the field, and through the communication from the base station, you can update the firmware version of that, which is quite an interesting feature. It was not available before 2018, but it's after the specification version 1.1, they have released this FUOTA. A little bit about Lora Network topology. As I mentioned, there's 2 network topologies that you can use. There's the star networking, which I'm sure you are familiar with. There's going to be a base station or a gateway, and then you will have a bunch of devices which will talk to that centralized device. A star topology is what is developed in LoRaWAN, MAC layer specifically. And this is what most of the people use when they're using LoRaWAN. But it does not mean that you are restricted or limited to a star topology. If you come up with an application where you do not want to be depending on an infrastructure, like a gateway out there, the possibility is out there. You can still use the LoRa device, and I will jump to this slide, and I will go back to the previous slide. You can still have your point-to-point communication using the LoRa. You may not need the LoRaWAN any longer because, as I said, the LoRaWAN is designed in a way that it requires a base station or a gateway. But there's still the physical layer, which is the LoRa, and has all the nice features of using cheapest spectrum, very low power, very robust, long-range communication. You have all those nice features still in LoRa, and you can use that for point-to-point communication. And as a matter of fact, I came across this company a couple of years ago. It's called Link. Probably you have already heard that because their product is already out there. What it does is basically, as you can see in this picture, it's a handheld, very small device that does not require any infrastructure. You do not need to have cellular connectivity, Wi-Fi connectivity, nothing is needed. Think about you're going out for camping with a bunch of your friends and there's no cell coverage out there. And each of you has one of these devices. It works based on LoRa, physical layer, and it has point-to-point communication capability up to 3 miles. It incorporates a little compass inside of it. It has the coordinates. It can communicate the coordinate with different people, and based on that, you can find where your friends are or how far they are, and give you the direction of also the distance. Now, this is one of the very neat and nice features or applications, I would say, of LoRa technology that this company has come across. They're not using LoRaWAN, but they're still using LoRa, and they are advertising it as a wireless communication way which does not require any infrastructure. I just wanted to bring this up to your attention because I know that many people, when they're talking about LoRa, the first thing that comes in mind, and it's already the web is overwhelmed with LoRaWAN specification, and everybody thinks that, okay, I need a gateway, but that's not necessarily a requirement. Back to this slide that we had before. We already talked about the radio coverage. As I said, if you want to have your private own network, you will need a net ID. If you don't have that net ID, you do not have any control over your network, and other people can use that or reuse that. And one of them, one of the 2 net IDs that are used for experimental purposes is what you already probably are using at UB, number 0 and 1. But if you go ahead and pay that money, you can have your own net ID and you can have your own private network. If your network is private, then you are not obligated to provide coverage for other people, although it's good practice to let other people to use your gateway. Or you can have a hybrid network. There are some perks to that. Some companies like Senet and Comcast are out there. They already have public coverage. They also let you use their gateway, or they will deploy it for you and give it to you as a service with private capabilities. But again, they always advertise to have it publicly available. Gateway-based station selection. Again, if you get to a point that you have your own company or you're proposing this to someone, there are very good companies out there like Multitech and Techtelic. Techtelic is in Canada. Multitech is here in the United States. 2 of the very well-known, I would say, vendors who build the gateways. So just the same as the end device, if you're really into LoRa, you can go ahead and create your own gateway as well from scratch. But this is usually something that people don't do because, gateway has its own implications when you want to create that. But I had one student who came to UB a while ago as a visiting student, and he himself at home, he created his own gateway because he was really into it and he was interested. So the possibility is out there. And things to consider when you're setting up your gateway, you need to think about the packet forwarder setup. I'm sure that you have heard about these, but I'm just repeating them, just throwing out some words for your future research. HTTP and MQTT are 2 of the main protocols that are used for packet forwarders. ADR settings, channel map configuration, radio coverage, maintenance, just to name a few of the things that you need to take care of when you are dealing with the gateways. And as I said, can I make my own gateway? Yes, you can. And people have done that, but is it necessary? Probably not. Lora Network and application servers. So now that we talked about the end device, you have created your own device or you're using one of the development kits. And we talked about the gateway, we talked about the network. Now it's time to connect everything to a, let's say, a cloud server, and then come up with an application and give the results to your end users. There are lots of these cloud services out there, Amazon Web Services or AWS. I'm sure that you have heard the names. Google Cloud Platforms, IoT Core, IBM Watson IoT Platform, or Microsoft Azure IoT Hub are just a few of the examples. So these are the areas that you may want to start, think about, learn about, make yourself familiar with the services that they offer. Because most of the companies out there that are offering any type of IoT application are using one of these services out there. And this is a very nice, animation from, again, Google Cloud that shows you the infrastructure of an IoT system. Starting from the device that is sensing or actuating, it will connect to the Cloud IoT core. Then inside of it, you have some cloud functions, you have cloud PubSub. These are, again, the terms that I will let you go ahead and search and learn about more. And then there's the cloud containers, which are going to be connected to your servers. Some analysis will be taken care of. And then, of course, machine learning stuff, which is quite a hot topic these days, and connection between the machine learning and IoT. We do some analysis. You have some data that you keep in your database, and you will communicate back to your device. Each of these steps that you see in this slide are quite interesting, and by itself is a word. So there are people who are only focusing on device and making new devices and thinking about different sensors and actuators that they can use on device. There are people who are working only on IoT core stuff. There are people who are only focusing on machine learning or the brain of it. There are people who are working on the analysis of the data. So pick one and focus on one, but try to also have a very good broad understanding of what is happening in this whole ecosystem. Finally, I have only 2 or 3 more slides. This is another example of some of the applications in the IoT world, and specifically this is a slide that I prepared for an emulation system that we have at Northeastern University. Jean-Yu, I'm sure that you and your research group are familiar with Coliseum. I know that a couple of groups at the University of Buffalo currently are members of the team, and they're using that platform. But in general, the fusion or connection between artificial intelligence, or AI, and Internet of Things is one of the topics that pretty much everybody, in this field of study is really interested in different applications of it. The trend is, IoT applications are getting just smarter and smarter by adding machine learning or artificial intelligence algorithms to it. The challenges are usually larger scale deployment of these devices is not really something that you can do easily. Let's say that you come up with a new application with new end devices that you want to deploy in a company or in a city. But before you are in a place that you can deploy your product out there, you may want to do more research. You may want to train your AI algorithm. You may want to run some deep learning algorithms and make sure that things work and things connect properly. But it's not time for you to go ahead and deploy all those networks. We are talking about thousands or hundreds of end devices that you want to deploy there, and then you want to run your algorithms thousands and hundreds of thousands of times to come up with a well-trained network. This is a time that emulation, simulation platforms can be quite helpful. So when you have a new application, one of the first things that you may probably do on your own computer, you can start thinking about some of the simulation platforms, and then there are some emulation platforms specifically for wireless communications. Here we are talking about wireless communications. LoRaWAN is one of the examples, but there are other technologies out there. NB-IoT, 5G NR is also these days trending. A little bit older technologies are still viable. LTE, SRS LTE is one of the other tools out there that you can use. And then you combine them and you put them on, software-defined radios that can basically emulate or actually work as in any of these technologies and devices out there. And then you will run the emulations. And then in a loop, you will train what you want to eventually test or deploy on your network. And once you're done, you will go ahead and deploy that on your network. So this is also another interesting area that I wanted to touch a little bit on that, and make you just familiar with some of the key concepts and some of the key words out there if you're interested to search and learn more. So to recap what we talked about, I have one more slide, as I promised, on the skill sets that you may need, for the IoT market, which comes after this. But just to review what we had talked about in this session, talked about the hardware evaluation kits and ready-to-use Lora nodes that you can, buy and find them in the market. And of course, we talked about the firmware coding skills that is crucial to learn. And you need to also be able to talk to software people. Those are your friends, and they are taking care of the back end and front end stuff. But really, when you work in a company or when you are doing your research, communication is really important between the team members. So that's the reason that I always suggest that it's really nice if you have a good understanding of the whole picture of the system and how things are connected and how things are working. Then you will focus on the area that you are most interested in. But if you have a nice understanding of the whole picture, that's when you can easily communicate with the other team members and achieve the goals of the team. We talked about the networks, the public networks, which is deployed out there. One of the companies in the United States is called Senet. They have quite a decent coverage out there. They have base stations in many major cities and some small cities. They have coverage in Buffalo. I think pretty much, I would say, very large portion of Buffalo at this point is already covered. They have, I think, gateways, one in North Campus and one in South Campus. Each of them will cover up to, I would say, a few miles, up to 10 miles. But you can also deploy your own proprietary network. There are access points that you have in your house, like the Wi-Fi access point that you have. There are LoRa gateways in that range that you can put in your house and will cover up to a couple of miles if you come up with the application for that range. And last but not least, Reuters says the global Internet of Things market was valued at 190 billions in 2018 and is projected to reach to 1,100 billions by 2026, which is a increase rate of 25% roughly. This $1,100 billion in 2026, this is the number that I found last year. I'm sure that if you look at the new reports, you will see that the predictions right now is even larger than that number. So there's room for everyone. If you're really interested in working in IoT world, I believe there's lots of opportunities out there. As I said, whether you want to do research in this area and stay in academia, or if you want to go to industry and work for large companies, or the third option, go out there and start your own company. I think this is an area that you can definitely prosper and be really successful. Last slide on the skill sets that are in high demand in the IoT market. Again, this is just a list that I could think of. It does not mean that it's a comprehensive and complete list. There might be other things that I'm missing here. But in general, a deep knowledge in digital principles is important. You guys, when you were undergrad students, I'm sure that you have taken that course. So recapping what you have learned there is really important. Digital communication and interfaces protocols, GPIO, UART, RS-232, SPI, I2C, and CAN, to name a few. You don't have to learn all of them, but knowing some of them, or just in general knowing what they do, is really important. Those are the questions that, you know, when you're doing the job interview, they will ask you. So it's nice to know them. Coding skills, of course, is important. This is not secret, but often I get this question that, you know, what should I learn? C, C++, Python, or, you know, many different things. I mean, the honest answer is really, if you're targeting a very specific job, they may ask you and they may require you to know a specific, you know, coding language. But honestly, for most of the jobs out there, it does not really matter. As long as you know one of them very well, and as long as you know the concepts of coding in general and, you know, algorithm design, you should just move from one to the other. So don't go down to the, you know, rabbit hole of, oh, I spent 1 year on C++, I know nothing about Python, so nobody is going to hire me. No, that's not really the truth, or the other way around. But knowing a coding skill is really important. System models such as finite state machines is what probably you start with, but that's not the alternate solution. That takes, you know, a whole session itself, but I just put it there for you to think about. Good knowledge of IDEs is essential. I just named a few: Eclipse, Microvision. There are lots of others. Sometimes it's important to know what processor you're working with, and sometimes, you know, like Microvision is specifically for ARM cores. It's sort of optimized for ARM microprocessors. But again, they are really similar to each other. Learning one will suffice. Git operations is really important, and it's becoming more and more and more important. So you may want to learn source and version control. When you're working in a company or you start your own company, it's really important to keep track of things that you are doing, being able to, learning about versioning and how to control the source and how different people can contribute to the same program, to the same code, is really important. It's not really hard to learn. If you already know that, that's great. If you don't, it's not really taking too much of your time, and it's always, a good time to learn. Learn Linux and shell scripting. You don't need to be an expert. Maybe some of you are not computer science people here, but having basic knowledge is important. These days, everybody is talking about softwareization and virtualization, and most of these servers are out there on either on Google Cloud or Amazon Web Servers. And when you get there, the first option is they will just give you a terminal, and then you have to learn about command line and shell scripting. So try to spend a little time on that and learn some of this stuff there. Containers and containerization, which is a huge word, is important and is becoming more and more and more important. That's again about virtualization. Again, pick one, learn it. All the others are essentially the same, and you can very, very soon catch up to speed with any of the others. Linux containers, or LXC, is one thing that you can start with. Dockers is the other one. Probably Docker is something that I would recommend, because it came later than LXC, but it's attracting a lot of people who are in this area. Kubernetes is just a platform that handles Dockers, but and K8S is basically the abbreviation for Kubernetes. Again, I'm just trying to introduce you to some of the words here. A little more on containers. In general, containers, what it does is basically when you have your application on your own computer, you will make a container out of that. And this can be used on any server. So all the dependencies, all the drivers, all the environment that you have created in your computer, if you want to use that in other places, that's the way to go. That's, containers, that's what you need. And it makes your application scalable. Cloud virtual machine environments, again, pick one: Google Cloud, Amazon Web Services, or Azure from Microsoft. Either of them is okay, but knowing those is important. And finally, just a few days ago, I came across a very interesting do-it-yourself type of, tutorial that you can connect a little Lora device to a smartphone. And the guy has already shared the GitHub code for a very simple application of chatting using the Lora communication between two smartphones. I just found it interesting. It popped up in my Google news feed, and I was giving this talk already, so I just put it out there for you if you're interested. And with that, I have the references here for you, and thank you for listening, hopefully, if you're not sleeping already. And I'm happy to take any questions.
Okay, thank you very much, Pedram. So I believe it's a great talk. I believe the talk has covered quite a lot that has not been covered in our regular lectures, I believe, because I gave lectures. So, and also in the last several slides, Pedram also gave some very useful suggestions and guidelines for you guys to develop your future career. I believe so. So okay, so next we still have some time for questions. You still can post your question here, and I also collected some questions, so I will share it with Pedram. So okay, so we can start from this one. Actually, the first question is, Pedram, can you see the question?
Yes.
Okay, so actually in our class experiments, we found that sometimes we try to connect to the LoRa gateway, but the connection request can be declined for many times because we can say do it successfully. So what do you think can be the reasons? We can get a decline for tens of times.
Mm-hmm. Well, this is a very general question. Many things could go wrong. Is this your LoRa or Sigfox? Because I know that you have both.
LoRa, it's LoRa. So we use the LoRa module. Basically, Joseph gave to us for our classes. I would say we eventually can go through the connection, but it may get declined for many times.
Mm-hmm. When you say it gets declined, between your end device and the gateway, and what is specific?
Okay, so I will maybe okay. Let me ask the student to share with you some experience. Okay, anyway, you can help share some experience, your experience using try to get connected with LoRa gateway, guys.
Because the first thing that you want to make sure is correctly registering your device on the network. And that part by itself can cause some troubles. But if the registration works fine, then I don't know. I can think of the coverage, if that is an issue, or potentially probably not, because you mentioned that you're in the class and you have the gateway there. What else could go wrong?
Yeah. Okay. Here in the chat area, Jianxin said, okay. He thought the request never made it to the gateway. Okay.
And you guys do have access to the gateway log files, right? Yeah. I think probably an admin account. I don't know who is the holder of that account, but I remember Joseph's TA, I think at that point was Amit. They had access to the log files of the gateways, which sometimes is quite useful. So when you say never made it to the gateway, the right way to check that is basically looking at the log files in the portal of the gateway and make sure that the gateway is not receiving those packets, or is receiving it, or is and not able to parse that and show that in the portal. Because these are two different, topics.
Okay, great. Okay, so another question is more, a little bit even more general. So now, we are entering, actually we are already in the area of 5G. And also last week, maybe, I don't remember, maybe 2 weeks ago, Northeastern just hold the first 6G symposium. It seems we are entering the 6G area, but hopefully in the next 10 years. So what do you think will be the role of LoRa or Sigfox, those very narrowband IoT technologies in the area of 5G and 6G? Could you share some of your opinions with us?
Right, sure. This is a quite interesting topic, and you know, between LoRa and whatever you have in 5G and 6G for Internet of Things, like the NB IoT, if you want to name that this way. There's always this competition between these two, and there are pros and cons to either of these two. As I had in one of my slides, I guess, one of the benefits of the LoRa is, you know, being low power, but at the other side, 5G and 6G are also trying to, you know, come up with some solutions that they compensate the bit rate, which originally they can provide, you know, way higher data rates than LoRa or Sigfox, but you know, they are starting to be creative and lowering the data rates and, you know, compensate for that with, you know, longer battery lifetime, or let's say less power consumption. But my view is, I think LoRa is still having its winning card or the ace card, because that is using the ISM band, and you can deploy your own network, which is something that you cannot do with 5G or 6G. In 5G and 6G, you will have to subscribe to a network. You will need that SIM card, you know, like old days, right? You will have to subscribe to the network and then pay some premium to use that network coverage and then come up with your application. But in LoRa, you can literally have your own network without any need to pay to anybody, right? Even for the gateways, you can deploy your own network, your own gateway, and there are companies out there who will take care of the networking side if that is too much of trouble for you, if you don't want to deploy new servers and collect the data from the gateway and put it in the front end. There are companies like, as I mentioned, Senet, Comcast, lots of other companies out there that will provide this service for you, but still you own your base station, you own your network. This is a private network for yourself, and you can deploy it in, let's say, in a company who, for whatever reason, do not really want to, what do you call it? Send this proprietary data that is collecting from sensors to the world outside, whether it be for security reasons or maybe loss of connectivity or connection to the 5G or 6G, or not willing to pay for that service, and they wanted to just keep it private to themselves. So that's one of the things that I guess is quite interesting about LoRa, besides the fact that it's very low power and long range because of the physical layer, which is also unique, and you don't get that in 5G or 6G. Those are not based on cheaper spread spectrum, and of course, that itself has its own nice features. So I guess both of them are quite viable options for different applications.
Okay, great. Thank you, Param. I have several more questions here. So the next question is, would you like to get to know, we would like to know more about LoRa ecosystem, devices, core, blah, 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 blah. What can I learn more in depth about each of them? Are there any applications of this ecosystem in any company? I believe you already gave some suggestions at the end of your talk. Do you have anything to add?
That's right. I will share the slides with you, Jangyu. I'm sure that you can.
You can go ahead to share it.
Yeah, and feel free to just share it with all the students. But as I mentioned, in general, if you're specifically asking for the ecosystem, I'm not clear on that. But as I said, if you're worried about which one of these services out there you should use, like, shall I go ahead and learn only Google Cloud, or do I need to learn Amazon Web Services, or which one of them is more, popular out there or more interested? The answer is, just pick one that you feel more comfortable with, learn it very well. transferring your knowledge from one to the other is going to be a piece of cake. So it's going to be very easy. And if you're going to be hired with a company, they don't really care. Sometimes they may, but it's not their decision-making key factor, I would say. As long as you know the concept and you have worked with one of these platforms and you can demonstrate your knowledge, I'm sure that they don't have any issues of you learning their new platform. But as far as their skill sets, again, my last slide are some of the things that I have seen in the past 3 to 4 years, both in academia and industry. Those are the things that I guess are the minimums that even if you don't know all the details on all of them, it's nice to know in general the concepts and making sure that you understand each of them is used for what part of this ecosystem, and then try to specialize in one or two, and then based on that try to find the job descriptions that are mostly close to what you have learned.
Okay, great. Thank you, Pedro. So I believe this is the last. Last question. So would you recommend the SIP SIP modules for experimenting and the project work, or can we start from scratch as a beginner and build up from there?
Well, here is the order that I recommend you start working. First will be off-the-shelf development kits, because they already have all the components and everything, and they give you the interfaces, like if you want to connect it to a sensor that supports I2C or CAN or whatever. It makes your life a lot easier if you're just in the proof of concept step, right? So you get one of those evaluation kits and or development kits, and those are really come at very inexpensive prices. I'm sure that you can afford it. So you take one of those, you work on the application. Once you have that proof of concept, if you're really serious about that, and if you want to go ahead and present that idea to someone, still that's fine if you use that evaluation kit, unless your focus is on designing a new device that lots of companies can use, which I would say very rare people are focusing on designing a new device. Most probably, if I understand it correctly, and feel free to write in the chat, you are thinking about a new application. If that is your case, if you're working on a project which is a new application of IoT, I would start with the evaluation kit. Once this is developed in a way that you can present it to funding agencies, and after you raise some money, then the next step will be using the SIPs, because those are the second easiest way to create a new device. You will need a very basic PCB design, and you will put that SIP that already includes everything inside of it. And then that's going to be your second step. And quite honestly, even in commercialization step of your company, you can still go ahead with SIPs, because those are very reliable solutions. And if you're in a scale that you are just producing hundreds of your devices, SIP is the perfect choice. Then the next step will be designing from scratch. But that is only for companies who are thinking about millions of those devices out there, and literally pennies and cents count for them. So rather than paying $2 per SIP, they would rather buy the chips at sub-dollar values and then put it on a PCB, and then bring the cost down from $2, let's say, to $1.60, because they are producing millions of them, and then those pennies make sense there. But at this step, as I said, evaluation kit first, then SIP for medium range production, then I would go for designing from scratch. And who knows, in future, if you're doing billions of devices, you may want to go for SoC custom design. You talk to ARM, you will tell them, hey, I want you to create a new chip for me. But that's a whole different story.
Okay, great. Thank you very much, Pedram. I believe this is the last question. Hello, guys. Last chance. If you have any question, you can post it in the chat area. We may have time for one more question. Any questions? It's a very good opportunity. Okay, so Stephen has a question. So is the advantage of spending the designing your own firmware only for large scale market targets, I assume most companies won't spin their own silicon.
Well, again, it depends on the scale that you're talking about. Having your own silicon, if you're talking about, a new SoC design, or these days people are talking about RISC-V, that's really when you want to think about it when you have a large company and millions of products out there. But as I said, as a startup company, I would not really, I cannot think of any reason to go for, your own silicon. But the firmware is something that, at mid scale, you would like to have a very decent firmware that you know all the details, and you can start, modify that pretty easily.
Okay, great. So we have one more question is coming up. So does bidirectional traffic do more harm than good in LoRaWAN based on LPWA networks?
Well, if I understand your question correctly, you're concerned about the bidirectional communications in LoRaWAN in general. I answer it in the following way. Well, these okay, good. So, well, LoRaWAN and Sigfox, both of them, are designed to have to support bidirectional communication, but the expectation and the way that they have designed is mostly for uplink communications. And by uplink, I mean from the device to the gateway. And again, this comes from the application, right? Because most of the applications in IoT, you are sensing something and you're supposed to, send that data. One of the bottlenecks for downlinking, specifically, and especially if you are in a star topology, which is what people are using, and as you mentioned, you're talking about LoRaWAN, so I'm expecting that you're thinking about, the MAC layer and the, network protocol. Transmission from a gateway takes some of the resources of the gateway, right? And that's basically broadcasting. Or of course you can unicast, broadcast, or multicast in LoRaWAN. All of those are defined. But again, you are taking resources, and by resources I mean spectrum resources in time, frequency, and whatever you're using from the resources and the channels that are available. And if you have tens of thousands of devices out there, but only a few gateways, all of them can communicate to these gateways because they communicate at different times. But if your gateway starts to do the downlink, then it's occupying that whole spectrum resource that is available to all of them. So it's really recommended that you minimize your downlink communications and only send control and very critical and important messages in the downlink. And as a matter of fact, companies out there, again, like Senet and Comcast, all of them, when you get to a point that you want to, purchase some service from there, they will charge you 4 times. That was what it was like a couple of years ago. They may have changed it 4 times more for one downlink message than sending an uplink message, because you're using the resources in a harmful way, as you indicated in your question. So when you send an uplink, they will charge you, let's say, 1 cent. But if you send a downlink, they will charge you 4 cents because, again, you're sending the same message, but you're using more resources. So yes, it's recommended that you minimize your downlink messages.
Okay, thank you very much, Pedram. I believe we are running out of time. So, okay. So if you have further questions, feel free to contact Dr. Pedram Johari by email. And also, we hope to invite you again in the future years and also the events to give talks, maybe on the same or different topics. Now you are working on, I believe you are working on different topics. So, okay, great. So before concluding this class, I propose to let's give a big thanks to Dr. Pedram Johari.
Thank you. Thank you.
Okay, thank you, Pedram.
It was a pleasure, and as you said, I hope that we can continue this in the future years. And by the way, if you still have your basically exhibition, I don't know if you're doing it online this time for the projects of the students.
Yes, we have it. Actually, we hold on. I will share with you something. So, okay, so I will share. What is okay?
I mean, you can share it offline with me.
No problem. I can share with you something. I'd like to share it. So. Actually, this year we are organizing the event again. So it will be can you guys see my screen?
Yes.
So we are organizing this event again online on November 20th, and we haven't finalized the program, but the program is almost there. So we have speakers keynote from this guy, the president of Sigfox USA. Not about Lora. You will give the Lora. So this guy will talk about the Sigfox.
That's right.
And also other top speakers like this professor, and also Joseph, and also this Joseph. Actually, Joseph and Sassi will give a joint talk on the biomedical Internet of Biomedical Science.
Nice. Yeah.
And also
you'll see some of the work that I have done with them. Okay, that's nice.
Yeah. And Scott and also Luca will give a talk on the edge computing for the COVID-19 healthcare facilities. And also we have some speakers from Air Force and also the PI of the Apple project. And also some other professors from about mobile edge computing. And also at UB, we also have a drawing facility, testing facility, SOAR. Chismari will also give a talk, and also Jason, and also some guys from Italy. And also we also have a panel about smart cities. The panel is organized by New York State Wireless Association. The panel will be the panelists will include the this panel speaker from Buffalo Urban Development Corporation, and also from Verizon, from Verizon, and also from Syracuse, and also Kansas City. So finally, we have some other talks about from GE Aviation and also Qualcomm. So it can be a very nice.
That's really nice. Yeah, this is a very complete and comprehensive list. I mean, it's really growing really fast. What is this? The third year that you're having?
This is the second year.
Second year.
But I would say actually this is the fourth UB6 IoT Expo. So last year is so actually this event was growing from the IoT Expo. I was inspired by this idea. So just to try to get some local and also local IoT companies, our collaborators from industry, government, to involve them to serve as a platform for us to exchange ideas. Apart from the class project will be demonstrated here. We have poster, we have demo. Students will show a video, YouTube video first, which will be the link will be provided here. You can ask questions for different projects, and also we also collect collected the posters from the department and also CSE department, and now they already have several posters and it's still being updated. Later, after the program is finalized, I plan to share the links in the institute of all our speakers, including Northeastern. I believe you will receive the emails.
Sure.
Yeah. And also after from that, there will be several invited talks. I believe you will be the first invited talk before the event. So the talk is you are the first one, I believe. Yeah, you are the first one. And
yeah, we talked
Thursday,
a couple of days ago. Yeah, he mentioned that he's doing it on Thursday.
Yeah, we will have a talk on intro body. Then Lorenzo will give a talk on drone networking, and American will give a talk on water networking. I believe this will be a great opportunity for our students to learn different, different types of IoT.
These are all my colleagues, so I highly encourage you all to attend all those sessions, and I'm sure that you will enjoy each and every.
Yeah. I expect a lot from just from your talk actually. So it's great. So now this morning we just had a meeting, organizing committee meeting discussing the program. So hopefully we can finalize it very soon. So I will share the program with the link, and also the link which will be via the Blue Jeans. The Blue Jeans is sponsored by Verizon. You know, Blue Jeans was acquired by Verizon. So we'll be in touch shortly.
That sounds great. All right. Sounds
okay.
like
okay. So everything is good in Boston?
Yes, pretty much. We are mostly working remotely, especially the people who are only need their computers to work. But as you remember, there are quite a few students and researchers who need some of the equipments in the lab.
Yeah.
And they go there often. I myself try to go to campus once or twice a week. And I've just started a couple of months ago. Things are going smoothly. Northeastern does the test for everybody who's going to campus, so that's mandatory.
Yeah. I heard Northeastern test 3 times or twice every week, right?
That's right. The students will have to do the test every 3 or 4 days, and for faculty members, I think it's every 5 or 7 days. But
okay. Yeah, it's much more frequent than UB does. UB does do some lottery.
No, here they test every single person. But things are going forward. But I hope that sometime soon things will get back to normal.
Okay, great, Param. So we'll be in touch on the event and also on our research. So hopefully we can have some collaborations in the future.
Sure, absolutely.
Okay, thank you again. Much appreciated.
Thank you.
Okay.
Talk to you later.
Okay, take care. Bye. Okay, guys, we can conclude we will stop here today. So just stay tuned for the following invited talks and also the Buffalo Wallace Day event. And I would like to discuss with all of you during the lab time, if you are here, on the progress of your class project. I will see you again later. Yeah, there will be several more invited talks. You can check the website of the class, which is here. Of course, I will also share the link with send a email to all of you, including all those IoT major students, a couple of days before the talk. So stay tuned, please. Take care, please, guys. Bye.